Hello all, welcome to the second video in this .NET Microservice series. In the previous video, we looked at how to set up Docker environment on your local machine. Also, we looked at how easy it is to work with Visual Studio and Docker images. We can easily create Docker images and also run and debug it from the IDE itself. If you haven't watched the video yet, you can follow up the link here. The link is also available in the description box below. Based on these learnings in the previous video, we'll create our first microservice for a hypothetical e-commerce application. We'll build it using ASP.NET Web API, C#, Entity Framework and SQL Server. During the development process, we'll see how different elements fall into place and help us build a microservice running in your local Docker host. So let's get started. Welcome back. Let's talk about the application we'll be building throughout this series. Our hypothetical e-commerce shopping app will handle requests by executing business logic, querying databases and returning responses in HTML, JSON or XML. It should also support various clients including desktop browsers, running single-page applications, traditional web apps or mobile apps, both native and web-based. It may also expose endpoints for third parties to consume. Now that we have a basic understanding on how these things are going to work and we have the basic tools ready, let's start with designing our microservice application. So for this video, we'll develop an e-commerce application by creating different microservices required for that application. So to start with, let's create a catalog API. Let's create a new web API project and call it catalog API. So as mentioned earlier, we should enable the Docker support so that we have the Docker file also created. So let's go ahead and create the project. The project is created and we have a standard web API project with the basic middlewares already added. Let's add Entity Framework, SQL Server, NuGet package to the project. Let's add a DB context. Let's call it catalog context. Let me just move it to a folder and Visual Studio will just update the namespace for it, which I like, which is something very good with Visual Studio 2022. Okay, so let's add DB context. Let's add some DB context options. Okay, and let's override our model. I'll add few models for our project. Let me just quickly add all the classes required. So I've added 3 classes: catalog brand, catalog item and catalog type. And let me just quickly copy the properties. So for catalog item is the catalog item for our eShop and it is dependent on type and brand. For type, let's have similar properties. Let's go back to our context and add these 3 properties. So DB context is defined. Let's come back to program.cs and add our context to the project. DB context, we have catalog text, and let's set up few options. We'll use SQL Server and get connection string, and let's call it default. And let's add few other properties, that is, and we are setting up the migration assembly as this one and retry on failure. With this, we have added our connection string. Let's go back to our app settings and add condition string. So for now I'm not adding anything here. We'll do something else with this in due course. So let's come back to our context and set up few other things. So I would like to add some entity configs where I will define those entities. Okay. So let's call it catalog brand entity config, and I would like to derive it from the entity type configuration of catalog brand, and let's implement the interface. So for this one we'll just say builder table and name of catalog brand. So what this would do, it would map this entity to the name catalog brand, and it would be mapped to a table called catalog brand. And let's mention the key column, which would be cv.id. Let's also say properties cv.band and max length as 50. So let's come back to our context and add this configuration. So what we would like to do is model builder dot apply configuration and new catalog brand entity config. Okay. Similarly, I'll add 2 more configs for our 2 other models. So like this, catalog item entity config, and the next one is catalog type entity config. Few more configurations. So I'll just copy paste some ready-made code. Before that, we need to inherit. This is for catalog type. Similarly, let's do it for catalog item. So now configurations are ready. Let's add these configurations to our DB context so that these are applied to our remaining models as well. Next, let's add migration for our DB. So let's go back to terminal and run our command for the migration. So that would be .NET EF migrations. So in case you get an error when you're running this command, that saying this command is not available or some error, the reason could be that the tooling is not installed for EF migration, which is not now part of the .NET Core CLI, the default package. So you will have to run a command, that is .NET tool install global .NET EF, which you can see on the screen as well. You have to run that command, and once you have installed the .NET EF tool set, then you will be able to run this command. So let's give it a few seconds. Okay, there was some error in the command, so I had a typo in the command, so I have to rerun it again. .NET EF migrations, add initial create, and let's allow it to create the migration. Okay, so we got an error that a project doesn't have entity framework core design, which is something we missed. So let's add that and copy it from here. Okay, so now that's added. Let's run our migration command again. Migration is created and we have like setups, so everything looks fine. Primary key, foreign key, constraints, everything has been added. Let's move it here. It remains under data. Okay, so now our migrations are done, and let's go ahead and create some seed data. We'll create a class which would populate the seed data for us in our DB. So let's just create a setup for that. Add a new context seed. We'll add a new function, and we'll take catalog text as the parameter, and let's also get ilogger of catalog exceed as logger. Now I'll have to reveal the secret of why I didn't have a connection string here. So what I intend to do is to use the SQL Server, which is or the SQL Server image, which is part of Docker. So we will not be creating a separate SQL Server, but for the development environment, we will use the SQL Server image, which is available as part of Docker registry. So with that, one problem which we could face is when we are seeding the data is when we are initializing those containers, and what happens is the SQL Server may not be available when you are trying to seed the data. It may take some time. There could be some network latency and there could be some delay, because of which the SQL Server may not be available by the time the seeding code is running. So what we would implement is retry mechanism to seed the data so that it retries again automatically and our data is seeded to the database. So for that, we will use a library called poly. Let's create another method, or let's start from here. Let's call it policy equal to create policy. We'll just pass the logger to this and we'll return. So we'll install the package poly and it will be handle SQL exception. I can retry async, retry count as retries. Let's create a local variable retries and let's put it 3 retries, and we'll have a sleep duration provider where time span not from seconds, we want to retry in 5 seconds. Okay, and then we'll call a retry method, a retry action, which will help us log some information. So what it would do is whenever it is retrying, whenever it goes for a retry, it will log this warning that this exception has occurred. Okay, and we have to change the type. So let's change it to sync retry policy, and we would policy dot execute async, and this is where. So poly is, you can call it, it's a resiliency library where it implements various patterns like retry logic, circuit breakers, and it gives us easy methods to implement these patterns. So here we just have implemented a retry pattern. We didn't have to write any retry logic. We just had to mention what was our retry count, and again after how many seconds or minutes or whatever duration we want to retry, and our retry logic is set up. And when we call execute async, it would execute whatever we are going to define here, and if there is an error, it would retry again. So let's put the first method context.catalog_brands.in. So if we don't have any records in catalog, then we want to add some. Context catalog brands.add range async, and let's call get pre-configured context.save changes async. Now let's create this method. We'll change this to enumerable catalog brand, and let's put some static list for our seed data. So this way the seed data for our catalog brand is ready. So let me add some other methods for our other models. Similarly, I have pre-configured catalog item and pre-configured catalog types, and let's just copy this, change it for catalog types, create pre-configured catalog types. Similarly, we want for catalog items, and that's it. So our seed data is ready, but now we have to call it. So let's come back to our program.cs and comment this for now. We don't want to do it right now. Let's have a try catch block and some logs first. So log information on figuring web catalog API. Let's put it catalog API, or let's call it, let's do app name, and let's call it API and web API in. Okay, now using where scope .services.create scope, we are creating a service scope, and whatever services we are initializing or getting would be valid in this. So let's call it, let's get context. So scope.serviceprovider.get required service, and the service we need is catalog context. So we have our context and we need a logger to call our seed. So let's do that also. It says ilogger of catalog context seed. Now let's first, since we have our context, so let's call database.migrate async, so which would migrate or which would apply all our migrations so that our tables are created. Then we call catalog seed. And okay, so I think I did a mistake. And this to be a method, not a constructor. My bad. And we want the context to be called. So just to reiterate it, so not a constructor, I did a mistake there. So we created a method, we have created a method called seed async, which would seed our data, and in program.cs we are creating an instance of seed and we are calling that method. Okay, and after that we have app logger dot log information starting web API. And now since we commented this out here, we'll call it here. Let's call run async, and after that 0. And here in case of exception, let's dot logger and let's put it as critical. So we'll pass the exception and program completed and that's cool. So switched. So with that, our seeding of data is also complete. Now, as I mentioned earlier, we have to use the SQL Server, which is the SQL Server image, which is part of Docker registry. So to do that, what we will do is we'll add Docker Compose. Adding Docker Compose in Visual Studio is very simple. We just right click on the project, click add and click container orchestrator support. It will ask what is the orchestrator, that is Docker Compose. Target OS is Linux. Obviously we add using Linux, and what it does is it changes your startup project to Docker Compose and it creates a Docker Compose YAML file, and it automatically adds our service which we are creating, and it's already part of this file. So now to add our SQL data, we can create a new service, call it SQL data, and the image we want here is it's Microsoft's SQL Server 2019 latest, and we want to define our environment. So we have to mention, let's call it word, and okay, and the ports we want to run is, now one change we want to make is that this catalog API is actually dependent on SQL data, so we need to add depends on. That would make it dependent on SQL data. I have another file called Docker Compose override. So this is where you define your environment variables. You could also define it in Docker Compose. You can, like we did environment section here for SQL data, we could do a similar approach for catalog API also, but let's try it out from here. So here we can see that for catalog API, there is already environment section defined, and we have two environments variable also. So we will add a connection string. So in our development.json, you see the connection string is in a JSON format, and here the environment variable is in a single line format. So how can we define our environment variable? So what we have to do is, in that case, is stop with this part, and since the default is a sub property of connection strings in Docker Compose, we will put it as _, and we just mention default. So it would automatically interpret that default is under connection strings, and we can just put equal and mention our connection string. I'll just put it straight away. So here is server equal to SQL data. So one thing or one interesting thing here, it is that we don't have to specify IP or the port numbers on which this SQL server would be initiated. So by mentioning just SQL data, that mapping would be automatically done by Docker Compose. And since we have already defined that it is dependent on SQL data. So our database name is catalogdb and password is same which we created, and trust server certificate true. So with this, I think we are good to go. So let's build it and see that we don't have any errors. And everything looks good. So let's go ahead and run it. So usually if you're using a Docker CLI method, you would have to go and run Docker Compose command to run your Docker Compose file. But here you could just run the Docker Compose option here in debug, and it would deploy it in your local Docker host and would enable debug for your application. So let's run and see how does it come up. You can see it is downloading all the required images so that it can set up the environment. Docker Compose done, and you can see that our environment variable is set. And let's wait for our debug to start. So our migration is on, and let's hope everything, so I think we are good with it. Starting web API catalog, we can see the entry, so it should be up and running. Cool. So it is up and running and we don't have any issues with it. Now we have to create a way to access the data. So whatever we have is a default controller here. So let's go back and create a controller for our application. So let's go to this class and just rename it to cloud controller, and we'll probably delete everything whatever is here. And let's create a method to get at it. So let's have a get method. We'll have to call get items, and it will be probably sync action result async, and from query string we will take page size which is defaulted to 10, and then from query again we'll take the page index is 0, and also let's add string IDs, so we can search also based on start with. If our ID isn't null, then let's get items based on IDs. Get items based where to first IDs. I forgot to put a null here, and we'll have a method which will return a list catalog item. We'll have IDs dot select. Will be a comma separated list of IDs, and we'll select ID where try parse ID syntax, and all will be X. So we have couple num IDs dot all doesn't satisfy this condition, that is all are not valid, then we just return a new list, an empty list. It's fine. We will just get IDs to select. Get the value, we'll get items from catalog. So for that, let's instructor which would get the cover, and also the context, and now let's come back to here where we will get context not catalog items, where catalog item id dot select contains this id, and then we have to do a to list of things, and we return the items. Now if our items don't have any value, then we return by request invalid separated value, and then we'll just return the items. Now if the IDs are null, so we go by the pages. So create text not log items not long non-count async and page items, which by name let's skip page size multiplied by page index won't take good, but we would want to return it in a different way than how we returned here. So what we will do is we'll create a new folder and view models. We'll create a view model for this, and let's add a new item. We'll count items new model. Here we'll have page index, page size, and enumerable context. Sorry, context entity, and we'll put it here as entity is a class. Let me just add the code to speed things up. So let's go back to our controller, and we will return this. Let me return page needed. That's it, and let's run it again. So this time we are not going to apply the seed data because the data is already there, and we haven't brought down our containers. We didn't do a compose down in between, so our containers are still here, and it would be updating our changes to these containers. So let's see how that works out. Okay, so our app launched, and now our endpoints have changed. So now we have our get items. Let's try it out. Click execute, and we have our, so we have total 12 items. Page size is this, and we getting it based on the name. We execute this, get only 2 products because there are only 12 items. So let's try with ID 2 and 8. So we should only get 2 and 8. And what if we say 2 and B? So we get an error. That ID value is invalid as we have comma separated value, but yeah, error could be more specific. That must be a comma separated numerical value. Good, but yeah, you get the idea, right? So with this, we have created a microservice, and it is running using SQL Server as a container as well. And this approach is very good for having a local environment with your ready-made SQL Server. You can easily create it, dispose it, and this dev environment would work on any machine. So with respect to where you are doing it, you can quickly spawn an instance and you can start working. So that way it is very helpful. I'll put the source code in GitHub, and I'll provide the link in the description box below, so you can also go through that. With that, we have created our first microservice running on Docker container. In subsequent videos, we'll extend further on these concepts, add more services to create a multi-container app, and see how these services can communicate with each other. That's all for today. If you want to know about how to implement health checks in .NET, I have few videos on that which you can check here. If you want to host your static web application on a highly available service on Azure, check this video out. Thanks for watching. I'll see you in the next one. Adios.